Alright, we pick up where we left off in the last video for section 6. We were solving quadratic equations that gave us solutions that were imaginary. So here's another one. This one's a little different because we're not going to use the square root property like we did in the last example. And here we're going to end up using the quadratic formula. Notice I've got it written over here. So I'm going to first make my life a little bit easier by getting rid of these fractions by multiplying through by the LCD, which is 12. So I multiply both sides by 12, every term on both sides. And a little distributing. 12 over 1, 12 over 1 times 5 over 12. The 12's cancel. I have 5x squared. 12 times 1/2 is minus 6x. 12 times plus 1/4 is plus 3. And of course 12 times 0 is 0. This one does not factor. So a is 5, b is negative 6, c is 3. I'm going to plug it into the quadratic formula. I have the opposite of negative 6 plus or minus the square root of negative 6 squared minus 4 times 5 times 3. Again, the quadratic formula is right up there just in case you've forgotten. And that's all over 2 times a, which would be 2 times 5. So x is equal to positive 6 plus or minus the square root of, looks like 36 minus 60. And that's all over 10. Well, that would be 6 plus or minus the square root of negative 24. That's all over 10. The square root of negative 24 needs to be simplified. The square root, this is like a little scratch work here. The square root of negative 24 is the square root of 4 times negative 1 times 6. Square root of 4 is 2, square root of negative 1 is I, so this is 2i square roots of 6. So I'm going to replace this with 2i square roots of 6, and that's all over 10, which I'm going to break apart into two fractions. I'm going to have 6 over 10 plus or minus. I'm going to have 2i square roots of 6 over 10, and I'm going to write it in standard form, 2 square roots of 6 over 10i. I don't need to put the I in between the 2 and the square root of 6 since it's written as a fraction. It's not going to look as likely that the radical sign contains the I. But both of these fractions simplify. I can divide top and bottom by 2, so this is 3/5 plus or minus the square root of 6 all over 5 I. And these are my two solutions. And they're imaginary. Now if you have a quadratic equation, and you're not sure if your answers are going to be imaginary, there's a quick way to check, and that is to use what we call the discriminant. The discriminant is this part right here that's under the radical sign. It's the radicand in the formula. b squared minus 4ac, not the square root, just the b squared minus 4ac. And we can use it to discriminate what type of answers we have and how many answers we have. For example, if the discriminant is 0, you take the square root of 0, you get 0. Opposite of b plus or minus 0 is just opposite of b, you're going to get one fraction rational root. One distinct rational root. Now in the factoring process on problems where you get a discriminant of 0, it's the type of problem where you end up where you can complete the square or you can use the square root and a formula what ends up happening is you can factor it and you'll get the same root twice, sometimes called a double root. It's one distinct root, but you get the same answer twice, like 5 and 5, but we're not going to write it down 2 times. If the discriminant is positive and a perfect square, like 49 or 25 or 100, then we have, because then that becomes a rational number here, and what we end up having are 2 distinct rational roots. They're definitely real, but we can be more specific. They're also rational. We're going to get 2 of them. If the discriminant is positive, but not a perfect square, then we don't get the rational, we get the irrational roots. We'll have 2 distinct irrational roots. And if the discriminant is less than 0 or is negative, as the example shows here, we're going to end up with 2 imaginary roots. Now I have 3 examples over here in which we can use the discriminant just to figure out how many and what kind of solutions each one of these equations has. We're not going to actually solve for the answers, but we can find out how many answers there are, how many distinct answers there are, and what type. Are they going to be real and rational, or irrational, imaginary? So I'm going to look for b squared minus 4ac, my discriminant, where this is a, this is b, and this is c. It's already in standard form, So it's time just to plug it in. Negative 4 squared minus 4 times a times c is 16 minus 40, which is negative 24. That happened to be the discriminant on the example that we just did. Kind of a coincidence there, or did I write down the same one? No, coincidence. So this guy right here tells me that I'm going to have two imaginary roots. Imaginary. Let's see if I can spell that. There we got it. It's a little bit better. It's kind of difficult to read there. This one is not in standard form for a quadratic equation, one variable, so I'm going to put it in standard form. I'm going to kind of do it quickly. I'm going to subtract 10x from both sides. I'm going to add 1. 25x squared minus 10x plus 1 is equal to 0. A is 25, B is negative 10, C is 1, so that's negative 10 squared minus 4 times 25 times 1, which is 100 minus 100, which is 0. Well, if the discriminant is 0, we have one rational root. I think it's a fifth, as it turns out. So one rational root. And in this last example, again, not in standard form, so I'll add 9 to both sides. And then A is 1, B is 10, C is 9. So now I'll go ahead and plug in. So there's B squared minus 4 times A times C is equal to 100 minus 36 is 64. Well, here we have a positive value, and it's a perfect square. So that means we have two rational roots. Now you're not going to always have a page of notes with all this information written down in front of you, so it'd be to your advantage to memorize them because there are other applications.